Welcome to Future Talk. This is the program that examines the global impact of technology, both for good and for bad, and tries to see just where the new technology is leading us. On today's program, we're going to talk about a very unusual school called Singularity University. It's based on the concept that technology is advancing at an exponential rate and that we need to train leaders who can understand this technology and utilize it in order to solve mankind's most pressing problems without creating more and bigger problems in the process. A little later on in the show, we'll have a video of some Singularity students, most of whom are busy starting their own technology companies. But I'd now like to introduce my guest. Neil Jacobstein has been with Singularity University from the beginning and is co-chairman of the Artificial Intelligence and Robotics track. He's also president and CEO of Technology Corporation. He's been chairman of the Institute for Molecular Manufacturing since 1992, and he was the principal co-author of the Foresight Guidelines for Nanotechnology Development. He's also a visiting scholar at Stanford University. Neil, what exactly is the mission of Singularity University?
Singularity University is assembling a cadre of graduate and postgraduate student leaders to understand and facilitate the development of accelerating exponential technology and to apply that technology to solving some of humanity's grand challenges.
Is this a regular university? Does it have full-time students? Does it give degrees?
We don't give degrees. We're a real university. We're located on the NASA Ames campus here in Mountain View in the heart of Silicon Valley. We do give certificates, but not degrees.
How hard is it to get into Singularity?
It's actually quite hard to get in. We have a huge number of applicants for every slot. In 2009, the summer program had 1,200 applicants for 40 slots, and the 2010 program has 1,600 applicants for 80 slots.
So do you just take one course and then you're finished?
No, we actually have quite an extensive 10-week program planned for 2010. The first week is an orientation week where we're going to be bringing in experts on humanity's grand challenges, like water shortages and climate change and renewable energy transitions and hunger and global health. And then the next 3 weeks is focused on the core technologies themselves, biotech, nanotech, AI and robotics, ecology, and space and physical sciences. And then the next 3 weeks is a deep dive into those technologies and often accompanied by visits to companies here in Silicon Valley where students can get a hands-on look at the development of the technologies themselves. And then the last 3 weeks is a team project where the students focus on big grand challenge problems.
10 weeks doesn't sound like very much time to come up to speed in some of these technical fields. Are you really trying to give in-depth technology, or is it more training the entrepreneurial end?
We're actually bringing in people who are already experts in the various tracks that we have. We have a very high selection bar. So in AI and robotics, we might have several PhDs in AI, or in the medicine track last summer, there were several MDs. So we're bringing in people who already have demonstrated expertise in these areas, and we are selecting for students that have a real interest in entrepreneurial development, who've shown that they have either started a business or an organization or done an outstanding research project, and they have a passionate commitment to solving some of these grand challenge problems.
We were out at Singularity University a couple of weeks ago and we interviewed some students there. We're going to show that video of my interview with some of the Singularity students, and then we're going to come back and we'll talk about more issues regarding the aims and objectives of Singularity University. So let's go ahead and roll that tape.
Great.
Singularity University is located at NASA's Ames Research Park. You have to pass through a checkpoint to get in. Ames Research Park is one of the world's foremost space research facilities, and Singularity rents its space from it. Singularity is not a part of Ames, but the two have a lot of close ties and many overlapping interests, including space research, artificial intelligence, and robotics. When students finish Singularity's 10-week course, they remain part of the Singularity network and are encouraged to start their own companies. Jessica Scorpio recently completed the course. She previously served for 3 years in the office of Canadian Prime Minister Stephen Harper, and she has a bachelor's degree with highest honors in political science. She's now co-founder of a startup company called GetAround, which offers a new concept in green transportation. Tell me about your company, GetAround, which you're co-founder of, which was incubated right here.
Mm-hmm. Well, GetAround is a new company working in green transportation. And basically what we're doing is we're enabling people who own cars to share them with people in their social network and in their neighborhoods and at their workplaces and in university campuses, which we're going to be launching in later this year. We like to call ourselves eBay meets Zipcar. And we've developed not only the technology, but also the insurance product that lets us bring this to market. So it's the first ever marketplace for person-to-person car sharing.
Let's talk about politics for a little bit, because you're a political science major and you've worked in politics in the office of the Canadian Prime Minister. Do you see work in politics as part of your future?
Probably, actually. I guess I've always been very involved in government, whether that's student government, different leadership positions. I enjoy it. I find that when people are asked to step up and be responsible for certain roles, I like to be that person, and I'm pretty good at it. I really feel like I want to be someone who has expertise and experience to bring to the table. So I'm happy to work in business and get some of that experience, and then later on, if I feel the calling to represent a district or a area of population, I'd consider it.
Now, so what do you see yourself doing, say, in the next 5 or 10 years?
Well, GetAround is a bit of a long tail play. So
you're committed to that for the long term. You hope it'll be viable and be a long-term source of...
Well, I think we'll probably be profitable in the next 3 years, get in the black, but definitely to see this make a national impact is going to be a commitment of probably the next 5 years, if not longer. So I'm committed to doing that, and definitely see where that takes me. We know there's a lot of people interested in what we're doing, so it could be brought into a bigger effort, and I'd like to see that happen.
Another recent graduate is Shawna Pangaea. Shawna has a bachelor's degree in neuroscience from the University of Alberta, a master's degree from the International Space University in Strasbourg, France, and she's studying to become a medical doctor. She's involved in a startup that deals with disaster response. Shawna, what made you decide to go to Singularity University?
Well, it's actually a little bit of a funny story. So there were two things. So one day on Facebook, of all things, I noticed a lot of my friends were becoming fans of something called Singularity University. So I thought, well, what is this institution? I should probably go check it out. And then the second thing that convinced me to come here, when I went to the webpage, I saw their mission statement of taking, accelerating, and emerging technology. So taking the best of what we've done and what we are as humans, taking our creativity, our innovation, our technology, and pairing that with the worst of our human challenges in healthcare, energy, water, climate, and creating solutions that way. I was sold. Those are my two passions, so I had to come.
Now that you've taken the course, what specific area of problems are you interested in working in?
So there's still no definitive answer, but I'm definitely working on two of my passions right now. One of them is disaster response and improving the way in which we can affect disaster response through technology, smartphones specifically. That's one of them. And then in the bigger picture, global health is something I'm extremely passionate about.
What would you say is the most important thing you got out of Singularity University?
Wow, that's a hard question. There has been so much. I think the value of the people and the networks, because the minds you meet at this institution are unbelievable. They're at the top of their game. They're extremely innovative, driven minds, but there's no ego. It's just driven by a desire to, for lack of a better phrase, change the world and drive new innovations.
Now, what does Singularity University define as the major problems of the world? There are obviously lots of problems, and some of them are sort of counter, so if you solve one, it makes another one worse.
That's true. So actually, they didn't want to constrain us too much, but they did realize they had to give us a framework. So when we came here in 2009 in the summer, they gave us a little bit of a challenge, which was called 10 to the 9 plus. And that effectively translates into how would you positively impact 1 billion people over 10 years using accelerating and emerging technologies. That now as to how we took it upon ourselves. I worked with an especially talented team of 9 students of the original 40. We represented 7 countries, and this team was extremely driven. So we took one step further back and said, how can we positively impact 6.7 billion people? And that's where we came up with the idea of affecting disaster response, because whether you're talking about a tsunami in the South Pacific or an earthquake in Haiti or San Francisco, the need to deliver aid and assistance following any natural or man-made disaster is just as relevant.
Another graduate is Zubin Wahab. Zubin is founder and CEO of Red Rock IT Solutions, partner and chief technology officer of ImageWork Technologies, and he's now developing the software for CiviGuard, an internet-based startup that helps coordinate disaster responses. Zubin, tell me how the system works.
Basically, it's an emergency communications platform optimized for smartphones and the civilian population. And there's a groundswell of investment going on post 9/11 within these emergency operations centers to invest in intelligence, in information and first responder communication across these different cities. And with that groundswell of investment, communication with different first responders has been optimized over time. However, there isn't really an optimal way of reaching out to the civilian population itself. And that's really what we're trying to focus on.
So can we see an example of how the system works?
Sure. So there's 2 components to the platform. One is CiviCommand, which is the multi-touch decision execution platform. And then there's CiviCast, which is really our broadcast platform optimized for a smartphone. We're releasing the Android and iPhone versions first, and the BlackBerry and Windows Phone 7 versions are following next quarter. Once these platforms are out there, it allows a command center using CiviCommand to go ahead and log in and during a crisis be able to essentially model a scenario that reflects the situation on the ground.
And you can configure it to put out just about any kind of information you want.
Absolutely. So you can go ahead and identify a particular zone, so it's all multi-touch based, and you can go ahead and set up sectors. You can go ahead and modify particular areas that you want to be able to manipulate in terms of size and area. You also have the ability to zoom. And the other thing is this depends on mapping providers. So it uses Google Maps and Bing Maps. So the reason it uses both, again, is resiliency. Should one service go down, then the other service takes over, etc. And then you can go ahead, click next. You can replicate the crisis zone and notification zone. Otherwise, the notification zone can be much larger, whatever works. And once you go to the next section, you can also add custom exit points. So you can go ahead and add an exit point down there, another exit point up here next to the bridge. And then
that means the bridge is open, you can get over it.
Exactly. And then what you can also do is also identify which exits are closed. So the system has a very prioritization based system. So that particular exit, if it's closed, you can simply go ahead and use our slider utility, set it to 0. And what the system actively knows is that now do not send instructions to people that say go down this particular exit.
So that was a series of interviews with some of the Singularity University students, all obviously very intelligent and ambitious young people.
They're great.
Now, I like the idea that Singularity University is not just a school, but it also considers itself a network, and it actually helps the students incubate their own startup companies. Now, how does that work? Does Singularity provide resources to the students for their companies?
Well, we provide access to resources, access to audience at venture firms, and access to expertise, and access to talent to implement the projects. And students can either start companies or start organizations that are nonprofits or have a research project. I mean, they have a choice of what they want to do with their team projects.
Now, you mentioned earlier that Singularity is in the business of training leaders. Presumably, the students have already displayed some leadership to get
That's
into
correct.
Singularity, but what additional things do you teach them about leadership so they'll be better leaders when they finish?
Well, we teach them a number of things. One thing is to have a nuanced point of view towards grand challenge problems and problem solving in general. We teach them that few of these problems are problems in isolation. They usually exist in an ecosystem of problems, and they need to take advantage of examining all aspects of these problems in order to be effective problem solvers. We also encourage them to line up the resources required before they launch any venture, and to make sure they have the talent, the credibility, and the means to be successful.
Now, if the goal is to ultimately solve big problems, what are the big problems that you're talking about? Is it mostly environmental problems, or is it the problem that a lot of people just don't want to get along with each other? What's the focus here?
Well, we're focusing on a number of grand challenge problems, including water, renewable energy, global health, poverty, shelter. Those are some key problems that we're working on.
So is it about making life easier? If you can provide people with a better standard of living and more comfort, then they'll have fewer of other types of problems?
Well, I certainly think that it helps to provide people with better health care and education and shelter and freedom from poverty as a foundation for them being good global citizens. I don't think that there's an easy answer to the problem of terrorism, for example, but we try to have people have a nuanced point of view about these things, and that means that they understand that it's important to attack these problems incrementally, and when you can, using the power of exponential technologies so that you get massive scale.
Is it possible for technology to be a double-edged sword in that not only can it solve existing problems, but it can also create new problems?
Sure, technology is often a double-edged sword, and the critical thing is to make sure that well-intentioned people know that and take that into account. Sometimes we've seen examples, for example, in the introduction of halogenated hydrocarbons into the environment, where otherwise well-meaning people introduce these chemicals without really looking ahead at what their potential ecological consequences might be. So we would like to encourage people when they introduce nanotechnologies or biotechnologies or AI or robotics to think about the longer-term implications. And in fact, we have workshops on the implications of each of these technologies.
Now, you teach both artificial intelligence and robotics at Singularity University.
Right.
How do you see these disciplines as having a significant impact on global problems?
Well, let me use AI as an example. Today, we address our problems in much the same way that we addressed them when, for example, our nation was founded. We have a Congress, they debate points back and forth. They're often unaccountable for the way that they address the problems and the assertions that they make. And it's possible, in fact, to build augmentation systems that check facts, that amplify points, that connect facts, and that help people be more responsible problem solvers. So that's a way that AI can be used to augment human intelligence. AI can also be used to solve problems, narrow problems today, but eventually broader and more subtle problems in the future. And it'll eventually be able to do that with some human assistance and then without human assistance.
Now, some people say that artificial intelligence might eventually be more intelligent than normal human intelligence. Mm-hmm. Is that something that you subscribe to?
I think that that's likely to happen in the future. It hasn't happened yet. The kind of AI that we see in common application today tends to be narrow and domain-specific or very task-specific. And if people are interested in seeing some of these applications, they can look at the website of the AAAI and in particular an innovative applications of AI conference that is sponsored by the American Association for Artificial Intelligence. And there we've documented probably 400 plus successful applications of narrow AI in a wide variety of fields and addressing a wide variety of tasks.
Now, is artificial intelligence or intelligence of any kind basically about processing larger amounts of information faster, or is there another component to it that cannot be replicated by a machine?
Well, let's see. Human intelligence is not just about processing information fast. In fact, we're not really fast information processors today compared with the speed of machines. The advantage that machines have today includes speed, but eventually we'll see that it will include a wide variety of strategies that people don't use and perhaps new capabilities that people don't have today.
Can machines exercise judgment? A machine might be able to figure out how to achieve a goal given a set of resources, but can it set the goal? Can it decide what goal is worth achieving?
Mm-hmm. Well, machines today are able to set limited sub-goals for solving larger problems. They do this frequently in a process called backward chaining. They set sub-goals for larger problems that they're addressing. But in the sense that you're asking the question, to address it squarely, currently machines are addressing the problems that we want them to address. I suspect that in the future they will pose new problems and address those problems.
Where does the name Singularity University come from? What is meant by a singularity?
It's a term that's pulled from physics and originally referred to the event horizon of a black hole, where it's very difficult to see beyond that event horizon. And in this case, the event horizon is the advent of very advanced technologies, such as strong AI, or AI that is at human levels or beyond, significantly beyond, perhaps. And when you have those technologies coupled with nanotechnology in its advanced form of molecular manufacturing, which will do for humanity's relationship with molecules and matter what the computer did for our relationship with bits and information. It will basically blow the roof off of our ability to manipulate matter. And when that happens, coupled with ultra-intelligent machines, we achieve a kind of event horizon beyond which it's difficult to predict precisely what will happen.
Blowing the roof off of something always has sort of a funny connotation. Like you're never really sure that that's really what you want to happen. It seems like rapid change could introduce a lot of instability. So in our rush to advance technology, are we also considering possible instability and other negative fallout and making sure that we have contingencies for dealing with that?
Right. So the answer to that squarely is yes. We do talk about that at Singularity University often and deeply. There's no question that technology can have both harmful effects and positive effects. I personally am an optimist, and I think that technology has had primarily positive effects and a lot of negative effects, and I think they need to be addressed squarely with other technologies, not just more technology, but better technology. And by better, I mean technologies that are designed to work with nature effectively and technologies that are designed to have minimum negative fallout.
Is singularity itself part of a larger network? So, for example, if somebody in the government who's in charge of solving climate problems needs to find an expert on the topic, they say, well, who do we know who's an expert on this? Let's go to Singularity University. Has it reached that level of visibility where it's considered a valuable resource?
Well, we certainly have had government agencies come by and do workshops with us and do brainstorming sessions with us, and they've been great, really fun.
Now, you're located on the grounds of NASA's Ames Research Center. You rent space from them. Are there any ties between Singularity University and NASA Ames, aside from the fact that you rent space there?
Right. They're not just our landlords. They're our sponsors. They are actively engaged. We have lecturers from NASA Ames come in and also other NASA campuses come in and give lectures to the students. We have students working on problems that are relevant to the space program. I think that there's a very deep synergy there, where these accelerating exponential technologies have a lot of implications and possibilities for next generation space travel.
Is the space program considered an important part of solving problems? In other words, if we can't solve the world's problems, maybe we'll just leave and go someplace else.
I don't think that that's the idea. In fact, I think that what I've seen at NASA is that they have a very deep commitment to solving the Earth's problems. And in fact, many of the climate change models were built from satellite data that, that came out of the space program launching satellites.
Is there an underlying philosophy to Singularity University, or some kind of worldview that could be summed up in a few words?
Well, I don't think that there's a single worldview from the Singularity University faculty. We have a very heterogeneous faculty. I do think that we have some values in common. One of those values is that we all are convinced that these accelerating exponential technologies are going to have a very big impact on our world, and that people are not sufficiently aware of them and really haven't thought about the implications in a deep way. Another value is that we think that these technologies can help us address humanity's grand challenge problems for a very specific reason. The problems themselves are accelerating, and the problems themselves are massive in scale. And that's just the kind of problem that these technologies can address.
Okay. I'm getting the signal that we're almost out of time. I'm getting a little confused by the signals I'm seeing. 30 seconds. Oh, we have 30 seconds left? Yeah. That's not very much time, is it? Okay. Anyway, I guess we are going to have to wrap the show now. I have lots more questions I could ask you, but we'll have to discuss it offline somewhere.
I'd be happy to.
I do appreciate your coming in, discussing these issues. It's a topic that is dealing with important issues that I think we all want to know more about and get a handle on. I'd like to thank my guest, Neil Jacobstein, for being here today, and thank you for watching. Be sure to tune in next time for the next episode of Future Talk, and please visit our website, www.futuretalk.net. I'm Marty Wasserman. We'll see you again next time.